In this video, I'll show you how to solve the ALEKS problem called deducing the block of an element from an electron configuration. To solve this problem, you are definitely going to want to have a periodic table handy, and I really like ALEKS's periodic table for this problem because part of this problem is asking us to classify elements as metals, nonmetals, or metalloids, and ALEKS has got some good color coding for that. One of the things that we're going to be doing on this problem is identifying the block location of elements. And so I want to start by marking up this periodic table to identify the different block location. So this is terminology that we use when we're talking about electron configuration. The elements that are in the first two columns on the periodic table are sometimes referred to as belonging to the S block. So when we're looking at a question like this, it's asking you what block in what block is the element located. All of the elements in these two columns, these elements here are said to be located in the S block. All of the elements over here, all of these guys, this is the P block. So any element in this area is a P block element. The transition metals are in the D block. And then last but not least, the lanthanides and the actinides are all in the F block. Now, solving this problem is going to be a lot easier for you if you know how to use a periodic table to count off or to identify or classify an electron configuration. So for example, if I said use the periodic table to write the electron configuration of fluorine, and you said no problem, I know how to do that. That's 1s2, 2s2, 2p5. If you understand that type of notation, that's going to make this problem a lot easier because that's really the main concept here. If you don't know how to do that using the periodic table to classify electron configuration, I think it's probably worth your time to go back and take a look at how that is done. It'll only take you a couple minutes and it's going to make this problem a lot easier. So what we have over here are some generic electron configurations. ALEKS is using some letters to just sort of represent, it could be anything. This G means it could be any noble gas, although ALEKS does say lighter than radon. So anything not radon. And then it's using N's and M's to represent those principal quantum numbers like 1s or 2p or 3p or 3s or whatever. So it's like just using these to kind of stand in place of the principal quantum number. I think that this problem is a little bit easier to look at if we just kind of ignore those letters. So we really don't need to think about them. And what I'm going to do is just kind of jump in with the first example. And I want to do this one first because obviously that's the easiest one to do because it's a lot smaller than the others. And I think, honestly, that is easier if we just ignore that N, pretend like it's not there. So what this problem is saying is, hey, go to the periodic table and find every single element that has an electron configuration that has this general pattern, meaning some sort of noble gas, followed by some principal quantum number, and then S1. Anything that has that type of electron configuration. So it could be helium, 2s1. It could be neon, 3s1. Argon, 4s1. Krypton, 5s1. Xenon, 6s1. The problem says, though, not radon. Don't include that. So this is a generic electron configuration for all of these elements right here. Helium, 2s1, neon, 3s1, argon, 4s1. I'm not going to read through them all again. It was all, how far down did I go? All of these elements right here have that same general electron configuration. The first question that we're looking at is what block are all of those elements in? These 5 elements right here, they're all in the S block. And just so that you know, there's never going to be more than one option for this. Like all of the elements that you find when you're looking at these electron configurations, they're all going to be in the same column. All of them will be in the same column, and the elements that are in the same column are always going to be in the same block. That's just how it works. So there's always only going to be one to choose in this spot. These 5 elements right here, based on the color coding for ALEKS, these are all metals. Now, there are going to be situations where you may choose more than one of these options. So, for example, possibly you choose these 3 elements as matching up with an electron configuration. These would be P block elements, and they could be either metalloids or metals. You could choose. Or maybe you would choose these 3 elements. Again, P block, non-metal, metal, and non-metal, metalloid, and metal. So it is possible that you would choose here 1, 2, or all 3 of those options just based on, where you're located on the periodic table. All right, let's do this one next. Let's just work our way from the bottom to the top. Again, I do think it's visually easier if you ignore the N's and the M's. So what are we looking at? We're looking for elements that have noble gas followed by S2D10P1. So starting with neon, noble gas followed by S2. Here we have a problem because we need S2 followed by D10. 3s2 is not followed by D anything. So we can't start with neon for this particular one. Let's go to argon. For argon, it would be 4s2, 3d10, p1. So that would give us gallium. I'm just going to kind of mark that. We could try krypton. That would give us 5s2, 4d10, 5p1, so it would give us this guy right here. And that's really, we don't need to keep going. That's enough information. We're just going to keep going down this column. These are all blue, so they're all metals, and they're all located in the p block. Not so bad. All right, let's try our last one, my last one. Again, I'm going to ignore the N and the M. That is S2F14. We'll start with helium. 2s2, we're not getting into the F's yet, so we're not starting with helium. Neon, 3s2, we've got to go straight from the S to the F, so this is also not correct. Argon goes 4s2, 3d10, so that also is not correct because our configuration doesn't have the D electrons in it. Krypton, 5s2, 4d10, nope. Xenon, 6s2, 4f14. So this one, for this particular configuration, there's only one element that works because we can't start with radon, and that is a metal, and it is in the F block.